Hey, hi guys. So in this video we are going to discuss about the one of the concurrency pattern, which is poison pill pattern. Let's first go through my example to understand why do we really need it. So let's first check this example. So consider that we are having this kind of class where we are having simple this mean method and this process method, and we are running a loop here to process this function again and again. So here we do not need to do anything extra. Basically what will happen is this function will run 5 times. It will call this function 5 times and we are done. Now let's go to the next example. In the next example which we have here, as you can see, we are having two things. One is the producer, one is the consumer. So just to give you the little bit idea about it, so in this producer, the producer will keep adding the task to the queue, to the blocking queue, or you can just consider for now simple queue, and the consumer is going to start consuming it through the queue and they will start working on it. So here what is happening is the producer will keep pushing the values to this queue, and the consumer here is keep checking, it's keep polling from the queue, hey, checking, hey, is it the queue, have we got any new task from the queue, have we got any new task from the queue. It will keep checking it, and if there is any new task, it will start using it. Now you might be thinking that, hey, how don't you think we are wasting the CPU resources here? This way, let's say if producer do not push any extra resource or any other task, but the consumer will keep running this while loop. As we can see, we are having this while loop. This will keep getting running to just check whether we have got a new task, or not. So how we should kind of avoid these situations? So one of the way which we can do is having a shared variable, which is we are having here, which is stop here. So whenever the producer is done saying that, hey, I'm done, I do not have more task to kind of push, so it will mark this stop to true, and here the consumer will get to know that, hey, I am done with it, basically. So that, hey, we are not going to waste our CPU resources, and we can close this thread. This will only work in this case where we are having integer value is equals to q.poll. Now in this q.poll we have two types of operations. So one is the q.poll, and there is one more which we will see in another example, which is q.take. This is non-blocking. What does that mean is it will still this while loop will keep running and we will keep checking this is empty. So we are fine with this. Basically what I'm trying to say is, with this stop variable we can easily fix this problem which we were having in this consumer thread. Okay, now think, what if we are having multiple producers, what if we are having multiple consumers? How you will kind of avoid wasting those resources? Because you can say, hey, we can have more stop variables. Are you going to create stop variable for every producer or for every consumer? I mean, what I'm trying to ask is, how we will make sure that we are not wasting the CPU resources, because consumer have to keep check on the queue, is there any new task or not? Is there any better way to we can kind of inform the consumers that, hey, we are not expecting any more tasks, you can kind of gracefully shut down. That is the problem which we are trying to fix with this new poison pill pattern, basically. Okay, now let's go to this example. Here if you see, here we are using the poison pill pattern. So we are having this consumer, this is the consumer. You can consider that in this queue we are keep getting the task. Okay, this will keep running, this while loop will keep running here. Okay, now it will keep checking whether the queue have a new task or not. But let's say if we want to shut down this consumer, we can just send a message to this particular queue which we call the poison pill kind of task, or poison pill data, whatever you want to call it out, so that the consumer will check, hey, does the task is rated is poison pill? If yes, you can denote it in any way. You can say, hey, I will push the -1. So whenever the consumer read -1, it can consider that, hey, I am done, I can come out of my loop and I can do the cleaning and all the other things, and I'm done with my work, basically. So they do not have to waste more resources now. So we are checking, as you can see, we are checking here If the task is a poison pill, then hey, we are done. We have received the poison pill. We are shutting it down gracefully. What do we mean by that? Whatever work we have to do, we have to clean the memories or whatever extra work we have to do. The cleaning part, which is the post process, the thread or the process can easily complete that. Okay. Now there can be another way of doing the same thing. You can say, hey, we can kill the process directly, but that is not a good way of shutting down any process, because in that same process there may be multiple other threads which are burning out. Now we can say, hey, we can fix this problem by using the shared variable. Yes, we can. We can fix it. But how we will fix it if we are having multiple producers? Will you say, hey, I will have a stop for every producer, so that consumer have to keep track that, hey, this producer is done, this producer is done, this producer is done? Or are we going to have a stop for every consumer? Don't you think this is going to be very complicated things to handle, specifically in terms of concurrency? The more cleaner way would be send the message to the queue. The consumers can consume it and they are done. Now there is another problem here. What if we are having multiple consumers? Hey Subhav, I mean, how this will work if we are having 5 consumers and we are definitely using the blocking queue? That means a task can be only processed by one of the consumer. So in that way, the better way would be to send the equal number of the poison pill to the queue. So if there are 5 consumers, you just send the task to the consumer. You just send 5 poison pill to the queue and you are basically done with it. And this way, this will be a better way of shutting down the consumers without breaking their process in the middle and allowing them to have a cleaner exit. Okay, now let's try to find it out, some reasons like why shared stop flags will fail in the real system. Okay, now one of the thing is the if you are using this consumer.take instead of consumer this one. So here we go to just 1 second. Yeah, so what happens is when you are using this poll here, it's a non-blocking. What does that mean is it will still allow to the next process to keep running on. That's why we are having this check here. It will not block the process here. It will allow it to run and this while loop will keep running. Basically, while loop statement will keep getting a hit. But if someone is using the queue.take, it is actually a blocking step. So if you use here take, what will happen is it will check if the queue is empty or not. If the queue is empty, it will wait for the next message to come in this. What does that mean? It will not move to the next statement, which is 41, 42 and then 39 again. So in those situations, we cannot definitely use the shared variable which we have used in the earlier examples. So there it will definitely fail. Again, the second reason is again which we have already considered. What if we are having multiple consumers? So, and sometimes we do not want to shut down all the consumers. Sometimes we do not want to kind of have the only partial shutdown, only allows only 1 or 2 consumers. In that case, it will be much more difficult. Yes, we can have more variables tied to every consumer, but that will not be a cleaner. We will have to handle all those variables and all those things. So I think the better way would be to use the poison pill. Now another reason would be, what if the queue is shared across the unrelated components? I mean, what do we mean by that is in most of the cases what we have seen is the producers and consumers are kind of related to the same class. Okay, but what if they belongs to the unrelated components? They are not directly connected to each other. It's kind of asynchronous, or they are not having direct sync ups, or they are not having sharing any having any particular memory which is shared. In those cases, definitely we cannot use those flags. The better way would be to again use the use the poison pill pattern. Now again, the next reason would be, if we are having that kind of interruption of using the stop variable, we cannot have much better control on the thread lifecycle. If we just have the use the poison pill pattern, as you can see, the code looks cleaner and you do not have to do much basically. The all the life cycle of a thread will not be disturbed in this way, and it will allow continuously to do whatever work it has to done after the exit of the thread. Now if we discuss about the benefits, just same kind of, you will find it on a repetition. So we can have a graceful shutdown. Basically consumer can finish the task and then see the signal and basically clean it up. Again, it's a thread safe, no race condition, no shared variable sync up. Basically we do not have to handle the race conditions about the shared flags. That is also a great that is also a great reason, because what happens is when you are having a shared variable and if you are not using having the proper synchronizations, that can lead to the multiple hazards. What if flag was set to false, but during but the producer set it to true, but because of the race conditions the consumer still went on continuously. I mean, those are the multiple cases. So yeah, I mean, these are the benefits which we have. See if we have anything more. I think we have already discussed this thread. Some of the examples which you will see is that people sometimes use another kind of denotations for the poison pill. Like they say, hey, we will send the negative one and we can kind of kill the entire queue. Those are other ways to kind of same thing to apply the poison pill pattern.